Hello everyone, welcome to another stream. How's it going? So today we're making a start on the game. So I guess we're starting from day one again. That's the way I decided to do it. So the game's working title, maybe it's the final name, I don't know. But it's called Man Shall Not Live by Bread Alone. It's from Matthew 4:4. If you guys don't know the game that we're working on, I highly recommend you take a look at the YouTube channel and you there we go. Should be popping up there now. Yeah, I highly recommend you take a look at the YouTube channel. There's a video on there which basically is called the game pitch. Take a look. Goes over the plan for the game that we're working on. And so that will probably answer a lot of your questions. But if you have any more questions, obviously there's a Discord channel where you can ask in the chat live on stream. But yeah. And there's also a way to support the channel and get access to the code that we write on the stream. Via Ko-Fi. Thank you for everyone who's supporting the channel. Really appreciate all you guys. So today we're working on the map generation. So what we see right now is a block, and the block is 60. What we plan on doing is making a procedurally generated map that renders, you know, a unique map for each playthrough. And we're going to start off by just making sure that we can actually render and not, plenty of voxels on the screen. And we might want to see like, hey, is maybe 16 voxels per block a good idea? Should we maybe make that, make these voxels bigger, right? Don't know. Because we'll be zooming the camera out. So off stream, I did work a little bit more. Effectively, I made it such that this is procedurally generated. This block here obviously just fills the whole thing in, but now we've got the code to literally do whatever we want inside this block here. You can press escape and get a debug orbit camera, and you can press escape again and get the debug free cam. Right, so we've got ways of inspecting how things look from different angles, but then we press escape again and it cycles back to the actual game camera, which is pretty cool. So hopefully, I think I busted that. Yeah, so I had to get the sort of mouse hide functionality and all of that working. If default camera should be show. Yeah, exactly. Anyways, we shouldn't be using that too much anyway. There we go. Right, so I have a quick prayer and then we'll get on with rendering a whole bunch of voxels on the screen, basically. So move the camera back, render a whole bunch of voxels, see how the renderer copes. If the renderer doesn't scale, well, we'll quickly sort that out. And then after that, we can move on to actually in the procedural generation logic, which would be very cool. I've got plans for using ISPC, if you know what that is. That's the Intel compiler, where it's a little custom language which allows you to basically leverage SIMD as if you're writing like shader code, but on the CPU. It's really great. So we'll probably be using that for the map generation. So rather than, it will be scaling across multiple cores, but also will be scaling across multiple SIMD lanes. So it's going to be as if it's going to have like tons and tons of threads, which would be pretty cool. Obviously, divergence starts becoming an issue, like you have in shader code, but it should be, you shouldn't get many divergence between the SIMD lane, between the SIMD lanes, so it should be good. Anyways, Father in heaven, thank you, Lord, for this day. We bless your holy name. Thank you, Lord, for being our great provider. Thank you, Lord, for everything you've given us. Thank you, Lord, for blessing us. Thank you for our wives. Thank you for our children. Thank you for all the cars that we drive. Thank you for, um, our home and our family, the fact they're still alive. And thank you for, the good weather and providing us rain. Well, um, Father, just pray help every one of my viewers get to know you before the time is too late. Because it's any time you could come and collect us, and it's gonna be a very interesting time. Very, as you say, 3.5 years into the tribulation is the worst time there'll ever be in history, and has ever been. So, Father, I just pray that you keep drawing any one of my viewers in and bring them to salvation. And I pray their family shall be saved as well in the mighty name of Jesus. And Lord, I just pray you help me complete this project. Pray you help me, guide me through every aspect of this project to make sure it's aligned to your will and not my own will and not the enemy's will. And just lift your name up high, Lord, and thank you for all that you've done for me and my family. Thank you, Lord. In Jesus' name we pray. Amen. Amazing. Cool. Yeah, so effectively the camera should really be zoomed out a little bit more. So 10 is not enough. Well, I forgot what the field of view is. Let's just have a look at that. If it be 60, that should be alright. So yeah, let's do 30. Let's see how. Right, so that's a block there. You can sort of see the edges of the voxels. Like if I zoom in here, you see I've got some rendering, just something in the shader to make it look like that, basically. You can still sort of make the outline, but you guys might not. Because on my 4K screen, you can sort of do it, but so let's see. Hey, what's going on? Bro. How do you do that thing again? There we go. Right, so let's go to the rendering function. So from the game side, the game thread, we can go to like logic render. And effectively, we just want to have this instance pushed out along the XYs. So let's just do it across the X. So we can bring up the wrong one, profiler as well. There's a scene shade pass, and essentially I'm expecting the voxel pass to be taken up a bit, but we'll just leave this here. All right. So we'll make that out, that's fine. Right, so let's do a full range. Let's go over Z. Well, let's just do X for now. 0, we'll do 16. And we're pushing world from local. Let's see how that looks. And we got a crash. No. Shame. Right, let's open it. Let's run in the debugger because I want to try and catch these things. Oh, okay. Yeah, 16 of those. this buffer. So why are you complaining? It exceeds the bounds of the buffer, eh? Did I not multiply it by the size of or something like that? So 336. Oh, wow. I didn't times it by the element at all. Interesting. Yeah, wow, fair enough. Anyway, so multiply it by graphics VK. Model instance. The words is a U32 word. Lovely. Amazing. So, if we look over to the debugger now. There we go. All right, so to the right, when you go across the X, it's going up and right, okay? And up will go up to the left up here, yeah? So that's cool. Now, I'm not really sure if I like this camera angle. We might change it a bit. I'm not sure though. We'll see. Okay, so where are we going now? Let's just go back to the game. Right. Some more dock there. Just seeing what that was about. Okay, so let's do... Let's see if we get any performance changes. So anyway, we can do 32. So we maybe say like map dim, something like that. So we can just say 64. That'd be kind of map dim. Let's do Z. Now, we want to do X take. Let's do map half dim. So it's map dim divide by 2. Really, that should be float. Just in case we do something a bit odd. Map half dim. Z map half dim. And let's recompile that. And we've got a crash, so the debugger's picking that up, which is nice, and I cannot tell anything. Right, so the payload... And the payload is full. Okay, the render data array is full. Kind of crazy. Yeah, so we've got to be very careful, like, we don't obviously send the whole map to the renderer when it doesn't render it on the screen, so you want to have some kind of culling and stuff like this, and probably a coarse culling and a more granular one. But we'll see how that goes as we get on with this. So when we make this payload, the payload key. Hey, look, you're saying 1 megabyte. Well, 1 megabyte is clearly not enough. So let's say 8 megabytes. See how that goes. And it's still complaining, maybe? No, the material cache is now complaining. So 64. Yeah, we should probably not crash. But we did 64 by 64, right? So it's only 4,000 objects, right? So it's not even that many. Hey, Don. Thank you so much for the raid, sir. Exactly. How are you? How did the stream go? Didn't realize you were streaming again. Oh, my laptop died. Crying out loud. Let me get my Twitch up on my phone. Right, stream without camera for... Okay, that's alright. Right. See you later, Don. Good to see you. Thank you, sir. Appreciate you. Hope your family's doing well and God bless you. Have a good one. Welcome, guys. Welcome, Raiders. How are we doing? We're currently working on a game and a little custom engine, Ren and C, with GSL Vulkan. If you go to the YouTube channel, you'll find the links down below. There's a video which describes the game that we're working on, but effectively, the game is called "Man Shall Not Live by Bread Alone." Taken from Matthew 4 verse 4, and yeah, it's going to be interesting. So we're working on a procedural map to generate today. Should take a few streams, I reckon, but when that's in there, it'll be nice because there'll actually be content now that we can look at. And the idea is to try and build a vertical slice, build the start to finish of the game in a very minimal kind of way. We'll try and build like a vertical sliver, right? But then move it out so it's more of a slice. Add more features till you get a sort of a feel for the game. Make sure it's fun. But yeah, gonna be cool. Any questions, feel free to ask away. Okay, so the material cache upload has got a bit of a hacky bit of code in. So it's crashing specifically on 84. Yeah, blocks. What's this blocks thing mean? Oh. Oh, there's exactly 4,096 of them. No wonder why it can handle it. So, yeah, let's do, 64,000 of them. That ought to be enough, right? Come on. Come on. Why are you complaining now? Right now the voxel buffer. So the instances... Yeah, we need more instances apparently. Wait, hey. Yeah. Okay, I see. Hi there. Hey there, Combi. I was wondering if you would try to load one of those complex animations examples in Magical Voxels. In Magical Voxel. Yeah, I didn't really try and load them. Yes, we have for those who don't know, we just finished up working on a Magical Voxel importer. It works on a small subset of Magical Voxel. And oh yeah, so they had the T-Rex, wasn't it? The T-Rex might work because it's only one model. Yeah, we could probably import the T-Rex. The problem is with the T-Rex though, is the palette is too big. So I have to remove the insertion and clamp the material down, but it should work. I haven't tried it out yet. I should probably try it out. Yeah, I think we'll give it a go when we're doing the characters. So after the map, we can do it. I think. I haven't tried it out yet though. Yeah, when we use it, we'll give it a go. Mm, mm, mm. Yeah, so the voxel BK shared instances was only 1,000. Not enough. So yeah, I guess we'll do 64,000 again. So we're gonna have to have a way to sort of cull these and not assert as well. Will be called CNMA characters in your engine. That's true, it very much will do. But yeah, the reason why I'm not doing it right away, even though it might make sense, is because, wow. All right. Is because the map generation, yeah, it just would be great to get the map generation done first, you know? And then you have the characters sitting on the map, basically. Right, so this is 64 by 64 by 64. Each one of those blocks has 16 by 16 voxels, hence why it looks like a big old grid, right? So, what's the performance like? It's a good question. Oh, for crying out loud, this mouse cursor's gone. Right, so 7 milliseconds. Not really the best. That's when it's full screen. Let's bring it down a bit, and it's crashed in it. No? Right, it's about 5 milliseconds. So I'm curious why the game view angle, that's the game view angle. Oh yeah. So I think it needs to be looking up more. There's something about it. Let's get in there with the yeah, maybe we need to put a character in there or something. Yeah, maybe we should, because then we can get a sense of scale. Do we do it? Yeah, we can also just put some blocks down, right? Yeah, let's just put some blocks down, it'll be quicker. Right, so I'm glad that's kind of working. So we could... What is our logic again? So if you XOR... If you just do X, XOR Z, and 1, isn't it? Something like that? I think that's the logic. Just do like a grid pattern. I think that'll do it. I'm not sure. So we will do that for just doing a little 8x8 or something. So we'll do that around level 0. It's just the next level up here. See how that looks. No. Oh. Ah. Weird. Hmm. It keeps crashing in the same place now. What have we done? We've only added this. Right, where did this happen? So 105. So apparently it didn't call begin render. Right, let's look at that. So let's put breakpoint here and see if it triggers after we do it next. It does, okay. Interesting. So but it seems to be crashing on a different thread on this one. Failing to find a window for some reason. Oh, this is interesting. Right. So you have one entry, which you can't necessarily find too easy because it's a hash table. But you should be able to look in the Windows pool, look at entry 0, and find it. Yeah, the OS ID is right there. Bum bum bum. Yeah, it's the same one. So it looks like the hash table. Yeah, that's been set up again properly, isn't it? Okay. I wonder if it's something to do with now the fact that the thread is doing more work. So there's like some race condition or something going on. But it's very odd. But yeah, it seems like there's some memory corruption or something. It would be good to use the address sanitizer because that'll make things easier. I haven't got that set up yet. Yeah, it seems to be crashing in different places. What's this one complaining about now? uh, so this one seems to be pointing to a function. um, something bizarre is going on here. Come on. I'm a bit confused, honestly. Right, let's delete the build folder. See how that helps. Yeah, I wonder if it's worth just getting the address sanitizer plugged in, because we can just run it and it'll pick up on a lot of things. Yeah, see, how can command buffer begin not be called? Ah, you know what? There's an error. Yeah. So here's what it is. So the window's maybe not available, so it returns early, and therefore it doesn't actually begin command buffer potentially. It's looking. That's the IO. I wonder if it's something to do with the swap chain or something. No, that happens later though. It's rather confusing actually. Oh, for crying out loud, what are you doing? There's a terminal with the build system open, that's why. You close in it. Cool. Right, so let's just follow through this one here. And what we find out is it should do a command buffer begin right here. You're not going to give me that? 1. Okay. That makes sense. Right, so it was happening on like a resource barrier. Here we go. So yeah. And here we go. Right, here's the line where it should supposedly crash. The active frame index is 0. Bum bum bum. That is very strange. What made you do that? Something made that tick. Yeah, I feel like we've got some memory corruption going on or something. That's a frame end, isn't it? Yeah, frame submit. So, yeah, I think that's... Yeah, exactly. Quite bizarre. Let's restart that, because, yeah, they'll crash again. Yeah, there you go. Right, so I think it's not actually crashing in this code here. It just points the wrong thread, maybe. Just my guess. The debugger. That's what I think is going on. Okay. So this is graphics in it. Frame starting the render. Now we want to put a watch point, right, on that. This guy here, yeah? So you want to put an address breakpoint? That, come on. Oh, I've already got that now. Yeah. Cool. So put the address breakpoint here on right, and then we just let it run. Right. So I'd be interested to know. Right, let's run that again. Yeah, the frame index value got set to something really random. Something weird is going on. What's... Right, let's try that again, shall we? Okay, here we go. So the graphics in it. So we get past the initialization. That's not the problem. Yeah, it seems to be some bug or something. Strange, it's been working fine. Right, here we go. So we're past initialization. So it's on frame index 1. So we've got this here. We want to... Is that an address location though? Yeah, it should be it. Right. Right, still 1. And it's changed here, like, but not sure when it happened. Yeah, it's one of these buffers is overflowing in here and causing that a problem. Got to find it. Although the debugger's not breaking on it. So I wonder if I have to put the address in there or something like that, but don't know. We'll just do it manually. So let's give it a restart. All right, here we go. Okay, so that's the address right there. You see it? So we'll just poke that in. So it's 0x. I can't see anything. 7FF, CA, 4F. Cool, let's give it a go. So step to next. There we go. Just what we're looking for. So this is where the problem's happening. So this blocks thing must overflow. Oh, yeah. I see. So blocks materials cap is not right. Gotcha. Right, we finally found it. So in the materials upload, there's a bit of a hack in there just to support the voxel, the prototype voxel graphics for now. So this needs to actually be multiplied by the palette app. So multiplied by 16 basically. So there's enough room in there. Ta-da! See, that would have been caught by the, there we go. That would have been caught by the address sanitizer if we had one set up. We should do that soon, it'll be cool. Like, it really catches so many bugs, you know. Alright. So if we take a look at the ground, we should see something. Although I cannot. I was expecting to see those. Did I remove them? I don't think I did. They're right here. And they're on floor 0. So I reckon they're always... Yeah, I forgot you do that grid thing. Let me see if I can find it. I need to remember this. I keep forgetting how you do it. I've got it in my old code base, so let's have a look. Have a look. So it was like the debug in the shaders. Go away, Visual Studio, I don't care. There's like a debug. Is the invalid, that's what you call it. Invalid texture. Is it? That's our boy. Is on. That's the one that we want. So it's coordinate and yeah, oh, okay, so you and one it. So you're meant to be doing x and 1 XOR y basically, but we're doing z here. Okay. I'll do it. And that'll get you a grid. Although, where are you? Let's comment that out for a sec. Oh, there you are, over there. Interesting, out of view. Of course you're doing by a half dim, aren't you? Let's do 4. Interesting. So the fact that we're striding, we're not striding by the right amount. So, oh, we should be striding by 2, I think. Yeah, so it seems like the size of a voxel might be a little bit too big. Trying to figure out where we sort that out. So we've got signed norm is local space -1 to 1. That's technically a length of 2, right? So in the overworld though, when you have like a block, you want that to, it probably has a half dims of 0.5, right? So you should probably scale it down by 0.5. Yes, you should probably have, yes, I think it's mol matrix 3D, scale matrix 3D, and we're going to scale it half. Okay, so I think you want to do translate first, maybe? Have a look. There we go. Da, 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 da. So now they're split up in a nice grid. So this can help us distinguish what's going on. So we're not really, haven't got different colors unfortunately, but we could sort that out. But yeah, we did this now. So you can barely make any of that out because it's so small probably. But yeah, let's get different colors on there. Where have you gone? Oh, those ones aren't halved yet either. Sort that out. So that'll be map half dim. I don't see that grid pan anymore. Should we see if we can get some different colors or something? Those come on. Sort it out. But yes, the material's actually here. We could literally change that. So we've got full red, full blue. Why don't we just like make it full green? And that should help us see it. Quite nice. And the thing is, it's a no. So why is that happening? So if we was to get rid of this, oh, those are at 0. That's why. Right, -1. Good old copy paste, eh? And do we see our boys yet? The answer is a big old no. Why not? There they are, right there. They're blue. Why are you blue though? Diffuse specular, diffuse. Oh, interesting. I bet if they're just red, I think. Oh, wait a minute. These are using the wrong color system. We don't use RGBA10 anymore. We do something different. We do RG11. Because we wasn't using the alpha, so I thought I'd just change it. So this is why the colors are looking a bit weird. So it's RG11 B10. And we do RG11 B10 because we're doing another reason is we're doing the P3 color system. So one extended color palette. That's the thing, cool. Right, so I'm glad we found that problem. See, those are sort of more like a cyan, and let's bring these back in more like this pink now. So why don't we see them still? It's a bit weird. If we did -2, it seems like the depth buffer is causing problems, basically, is all I can say. That seems like what's going on. Is maybe the depth buffer is the wrong way around? Why else, right? If we keep moving it down and down and down, eventually you'll see it. There they are, right there. Or was 1. What's going on? Another glitch. Okay, so maybe you don't see it. So potentially what's happening is it's being filled up. 64 by 64 ain't yeah, that's the other thing. What's happening is we've actually run out of room. So it's not depth buffer. If we put these first, there's something in the renderer where it's silently failing. Yeah, that's it. There's something in the renderer where it's silently failing. So we locate that down. So there's something where it like voxel cache, upload, let's start there. So essentially, or maybe it's not fully uploaded them correctly. Could be one of the things. So it's not the voxel models, because if the voxel models were uploading wrong, then swapping them around would make the other one disappear, but we can see the pink in the background, so it ain't that. Model slices is, yeah, that's what that one is. So it's not that, and it wouldn't be these two either because they're, yeah, they're per voxel model but not instance. So it's probably to do with the instances. So with the instances, right, you fill the full thing up. It should be there and work. Let's look at this material cache pool thing. Right, we found it. Seems like the material cache pool, we're just sort of, in a very hacky way, just getting in there and grabbing it out. And, you know, with raw pointers. And the array wasn't big enough, basically. If I go back to game, if I swap these back the other way around, it'll work. Maybe not. So capacity for pool is larger than the number of bits the ID can hold. So larger than 24 bits, you say? Is that what you're saying? So that would be 64,000 times 16. Oh, come on. Do, 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 do. That's bit 20, isn't it? So why is that complaining? I thought we had 24 bits. Maybe I changed it. In that case, we'll just shift it around. Oh, yeah. What a shame. So I gave more than... I gave 12 bits for the generation. So let's make it go higher. So 24 bits, please. No, sorry, add another for F. Drop an F off there. Oh, come on. Right, that ought to do it, I reckon. Alright, still didn't do it, unfortunately. So we're not seeing those. Let's go back to the materials. I'm sure I've messed someone else up. Property words. Allocator. Need more property words, I reckon. Nah, that's not it, is it? No, something is off. So blocks. Effectively, we've hacked it such that every instance then goes over 16 materials and jams that in the... Right, yeah, so I think we need to multiply that by that pallet count as well. quite. Yeah, I think that is the case. How big's that property's word buffer on the GPU? Oh, you're made in a completely different place, aren't you? Aren't you? Because you're a static buffer. That's why. Yeah, but you're supposed to be multiplied by size of. Oh, you are. Okay. Right, so index times by palette capacity plus. So the model instance index. So stride over that many. Yep. How many words in a solid material are there? So it's 56 minus a 40. Yes, there's only 4 words. Huh. So 4 words. So number of elements times by 4 words. Yes, there needs to be even more in the property buffer. Right, found it. Times by a further 4. Come on. Not enough, is it? So times 8. Nope. How's that not working then? So start index. Where's that going? So start. Yeah, the proto material, I think, actually. It's got a limited amount of bits on it for the start index, I think. The words. I think that's what's going on. Where do they get uploaded again? Where's the material ID? Yeah, they're limited to like 24 bits, I think. Yeah, we're not exceeding 24. Or this might be. Because that'd be 16. Sorry, 64K times 64K times 16 times a further 4, won't it? Right, that's still under 24 bits. 23 bits. But yeah, no, I think if we go to graphics VK shared, basically you'll find graphics VK shared, the encoder file. There's a material. Yeah, there's 24 bits for the words. But it would be interesting to see whether or not. Oh. So where does this get called? So yes, calling it right here, isn't it? Do 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 do. So I wonder then if we look at this, we should assert, right, if this goes out of bounds. Because if that is greater than 24 bits, basically, we've got a problem. Overflow, we'll just say. Not that one, the start index. Or apparently not, but at least we've checked that's not the problem. Okay, so let's go back to those materials. I'm pretty sure that's the issue. If the reason why they're not showing up is the materials. Unless the instant... Oh no, it's the instances won't be enough because we just did 64k, isn't it? No, we did 64 by 64. And that's way larger than 64k, so we just made it 64k instead. Sorry, it's way smaller than 64k, so we just made it 64k instead. That buffer should be fine. Yeah, this must be the materials. Okay, let's have a quick look in here. Yes, we can't possibly be overflowing that. What's the next one that could be overflowing? So the material pool, we fixed that problem. That's fine. ID from material name. Not really allocating with that anymore. It's a bit of a hack. We're skipping that. Right, materials. This materials array, this is questionable. Oh, sorry, this comes from the... Yep, this is fine. The model instance, that's fine. Material index. Populate these guys. Where's the... Oh, the gloss, and that gets separately. So it's separately here, that's good. Then copy many, right? Copy that many words into the start index. From diffuse words count, that's cool, so it's 4 words. So you're saying just do them all. So it's count times palette cap times, that is it. Yes. And this would assert if it was out of bounds, but it's not. Yeah, that would assert if it was a problem. So we could look in render doc, that is a way, that's a way to do it. Maybe. Check the buffers at the back. Final instances that we're rendering and see why they're not rendering. It's probably our next best shot to give it a go. Right, so we open our render doc. Oh, it's showing up a decent color now. I don't know what happened there. Oh, did we, okay. Yeah, so usually what happens is HDR makes it look weird in RenderDoc. Oh, it's not nice. Game. Well. Apparently it does that anyway. It's probably expecting for... What is it expecting exactly to happen? I don't know. I thought, yeah, maybe the build system has to be running. Nope. um, yeah, you just can't double click it from outside for some reason. Great, what problem to debug, eh? It was working not long ago. How's the build system? Hmm. Why wouldn't Renadoc want to work? Or double clicking on it without a terminal? Or what is the system doing? That's new. Hey there, Benchilin. How's it going, sir? How you been? I guess we'll just avoid using Renadoc. Be alright for now. So we could get the the voxel instance, and just render them basically. So we know the numbers. Pretty good, awesome. Yeah, not doing bad, thank you. You know, we're finally getting started on the game now, which is pretty cool. You know, excited for that. We're on to map generation, which is gonna be really cool. So yeah, I'm not sure if you've seen the video on YouTube. There's a video on the YouTube channel going over the game idea and everything. But I plan on using ISPC. We're going to get there very soon. We're just on the rendering side of things. The Intel compiler, this one. So effectively, like bringing the style of shader programming in a way to CPU. That's what it kind of does. So it makes SIMD code look like regular code, if that's the best way to describe it. So if you're familiar with programming shaders, right, I don't know, let's say, yeah, so essentially it's a bit like programming shaders where you have like threads running in lockstep, but that just really means a wide SIMD lane. So we should be able to use this to make pretty fast map, procedural map generation. And we'll obviously multi-thread it as well, I think, but it'll also kind of be multi-threaded on a single core, which would be kind of cool. The tricky part is the shuffles, I would imagine. Right. Shuffles. That means, let me try to think in x86 terms. Because I know you got that shuffle intrinsic. I just forget what it does again. Just shifts them around, doesn't it? Yeah, you do with a mask, isn't it? What do we mean by... Maybe it's something I'm not quite sure what you mean by that exactly. But yeah, I think we can get that last and then debug it. So inside the we can debug print. So voxel, no, this is it, right? So if instance index, so what's 64 by 64, and then we did a few more after. That means then it's just, that's right, isn't it? Yeah, so 496 will be the one that we're looking at. So we'll drop a box around it, call it a day. The no Z testing, right, is right. So you can move items to other indices with the vector, right? You usually write a sequence of shuffles with a static mask, the algo, for accumulating things or whatever. Right. Oh, so you mean sharing? I see. I think I see what you mean. So, yeah, I see. You're saying that that's not too, you can't express that too well in ISPC. Yes, I think the equivalent thing you're talking about is in a read lane with a VGPR. I think that's what you're saying. So that's the terminology you would use in shader programming. It's not obvious what shuffles you might need with ISPC if you just look at in scalar code. Yeah, so in yeah, so you're talking about reading from a neighbor lane, right? So you have like a vector 32 of 1, 2, 3, and so on, right? Yeah. And you might be on this lane to read from this one, and yeah, so on GPUs you do wave read lane at or whatever, that's the HLSL for it, and you will put in an index of the lane you want to read from, and that will basically do a shuffle under the hood in whatever the architecture is. But so you're saying is on x86 it's a static thing, right? I wonder if they have that. Let's ask the AI. Intel ISPC wave read lane at equivalent. See if it can. Apparently there's this extract thing combined with uniform index parameter. Interesting. So there might be some restrictions. Is ISPC warp level programming, or whatever it's called, one invocation as has the lanes? I'm not sure if you call it warp level, but yeah, it's, you know, a warp in the terminology that I know for that is like what NVIDIA calls, yeah, like a SIMD unit. Yeah, I think tensor maybe, but yeah, in in AMD lingo it's called a wave, and HSL is called a wave. But yeah, it is that thing, right, where you're pretending like you've got many threads on a single thread by leveraging all the lanes inside of a SIMD unit, right? And the threads go in lockstep. I don't know why I did that, but yeah, the threads run in lockstep, so they're not real threads, right? That thing. Okay, so it looks like the lane operations exist in the source rather than being discovered automatically. Right, so yeah, you probably have to declare it, but they must be uniform. And uniform meaning... Wait, uniform meaning they'll all be the same on every lane. Uniform requirement. The index argument you pass into extract must be a uniform. That means it must be the same value on every single lane. So actually what that's doing is that's making that into a uniform, right? So they can only read from the exact same lane. If it varies per lane, you should use a C4 or a C while, whatever that means, or conditional branching logic accordingly. Okay, so it seems like, yeah, that might be a bit of a problem. But I don't think my algorithms require that at the moment, from what I guessed. But I guess simple operations probably have static. Oh wait, I missed what Mr. Davros said. The tensor accelerators for AI are at warp level, and it looks weird when you evoke them from shader program in a lane. Huh. I've not tried out AI, to be honest, and how that works inside NVIDIA, the tensor stuff. But I guess simple operations probably have static sequences that they generate for you, since there's no creative requirement. You can predict people will want that kind of thing. Like reductions or aggregations, one idea implementation depends on the hardware, right? Yeah. Yeah, the reduction thing, yeah, I see what you're saying. Alright. The thing about putting a box down, right? When you try and render the 4096 index, do a debug draw of a box, and this means that it is at least going through the vertex shader stage. Right, I see a box. Right, so it is going through this guy. So if I were to up this, run it loud. Oh, I can't do it anyway. Yes, we see the outline of the box. Yeah. Dun, 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 dun. So now, if we were to up this to like 5,000, do we still see it? And the answer is no. It's gone. So if I put this up to 100, it's still not there. Put it back, and it's here. So I think these numbers are right. Because if I put up to 100, are we going to see it? We still do. Put it up to 10. Still there. Why is it still there? 8 by 8. Yeah, 64 odd, wasn't it? And it's gone. Good. Okay. Yeah, this is good. So we're able to pinpoint the blocks that we should be seeing rendered, but we're not. This is great. So what we can say, I think, is do not render the ones which are less than this, and then see if they render, basically. So, and then we can look in our image viewer and see if they get rendered out into the the layer buffer thing, right? So what we can say is if you're less than this, then what I want to do is do some GL position of just 0 and just return. And that should... Right, now nothing's rendering. So I bring up the texture viewer, we look at the... for crying out loud. Can't see my mouse. Do 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 do. Is that because of that thing in OS Windows I put in there not long ago? Maybe set cursor, mouse visible. I don't know. Anyway, yes, there's this depth layer image thing, and if we just blue alpha, oh, I don't see anything rendering. It's interesting. So it must be. So if it's not rendering into this buffer, it means that it's not getting the voxels or something like that. What's the triangle ref got again? It's not able to sort of ray trace through the voxels or something like that. Oh, instance index 12. That looks like a problem. Because one shift F12 is yeah, there's the problem. So effectively what's going on is our sort of visibility buffer hasn't got enough bits in the right place. But I thought I had a thing somewhere to sort of catch that. Do 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 do. I thought there was a maybe there was only in the I covered. I swear I remember. Man. Where is it? There's no cert for it. Or is it debug cert or something? Why it's gone then? There used to be something where I would check the number of instances and then be like, hey, these aren't gonna fit. Oh, there it is, right there. Oh, right, it's for the number of voxels. Yeah, but those don't go in the layer buffer, do they? Oh, they kind of do. Okay. Yeah, so we want one of these, but for the instances. So cache upload. Right, so we'll just dump this in here. So we're saying right, this is great. So we've found another thing to keep an eye on. So we should really up that to 2 more bits, 14. So there is going to be a clear capacity on the amount of instances we can accept. So we've got to make sure we call those properly, basically. If your game had a rare bug that happens if you pause it for an hour, would you patch it before release to add a check that resets whatever nasty thing it was accumulating? That's an interesting question. It depends, right? Um, yeah, so the thing you got to evaluate is my code going to break something else, right? Because that's the problem with fixing bugs. Is fixing bugs can create more bugs. So you got to evaluate like whether or not your code runs, does your code only run when the thing resets? And if that's so, you're probably not making things worse, right? Because it already, uh, well, you didn't say what happened, but maybe if it like, yeah, if it crashes anyway, right, and you're just trying to make it not crash, then potentially you patch it, right? Um, but yeah, it just depends, right? How about how about you, Benjamin? Would you do it? One shift left, 14, so that's 16,000. So here we're saying the sort of instances count. Right. So for now, this will be fine. It should work. Oh, there we go. We fixed the problem. Right, so these boxes, I was just trying to get these boxes to display. And there was a couple issues. One was the material buffer wasn't big enough, so the materials weren't being there. And the other one was the number of bits in the visibility buffer, or we have a layer buffer, was actually too small, therefore was overflowing. So yeah. But now we can poke these on at the end and they will show up. So these just give us some kind of this grid is to just show, well, yeah, let's not do a separate grid on top, but it's interesting just to fix that problem. Here's what we're going to do instead. Rather than doing that extra grid, we'll just have this thing called color. And, if color, so col question mark that. So now it's just going to be a grid of either purple or cyan blue. Yeah, that'd be nice. Ta-da! So each one of these blocks has 16 by 16 voxels in it. So if we just get in there and have a look, you can see them. Bum, ba-dum, bum, bum. The idea, you have quite a lot of detail, but I don't know if that's really what we want to do. Maybe we reduce it to 8. But anyways. So I think we'll look at performance just to see how well it renders. I think we want to maybe do an opaque pass because this transparency pass is a bit silly. Crying out loud, why doesn't it? Can I fix this bug with the cursor disappearing? It's so bad. But 4 milliseconds ain't too bad there. It's only one layer. Can we do more layers and see what happens? Can I do a Y layer? Uh, let's do that, shall we? That's a really good suggestion there. Yeah, just stop them from pausing for too long. Good idea. Right, so here we've got a few layers, a couple of layers. Right, so looking down at that. Oh. Okay, so we can add more layers and it doesn't really add any more to the performance. Or does it? Let's leave that there. Let's add more wires. Right, save it, see what happens to the performance. I think it might have crashed because of it's reached the the maximum number of instances. So let's do one wire and let's just keep bumping up and see what happens. Right, so we'll leave that there. We'll bring out the profiler. Yeah, so that like 2 milliseconds there, yeah? So we bump. Oh, for crying out loud. So HDR flipped off for like a microsecond and it was just deciding to tell me it's a problem. I guess my code doesn't. I guess my code might be handling something a little bit too late or whatever. From when it checked last time, if it was compatible, maybe. That's probably what's going on. Anyway, so yeah, it's about 2.4 milliseconds if we open up another one. Come on, work on me, please. Don't crash. Don't crash. Okay. Open that in the debugger, see what's going on, but it might be something to do with right now it's like 4 milliseconds running in the debugger. Interesting. Oh yeah, it's because we did another layer. Right. Okay, now it's reloading just fine. Yeah, so it seems like when you do this sort of layering, it is actually it is running more invocations. Yeah, we could do I think it could be alright. Because we've got this like layer buffer thing and it actually tries to render every block, I think, and it will ray trace through it. We could do a depth greater op and an opaque pass, and that could be fine. Yeah, so effectively, for those who haven't seen what we've got, is we've got a layer buffer, I call it. So the idea is that so you have to do the voxel ray trace inside the volume. So each one of these grid cells is a volume of 16 by 16 voxels. And so you have to do the ray trace through this. Then it does the pixel interlocked and it reads in the depths and the objects and does a front to back and search to find where to insert the depth value. and then if it finds a place, it stores it back out, and this does it all with per pixel locking. And the reason why I did this is because I wanted to have order independent transparency in the engine. But yeah, we shouldn't be using this all the time because it's not that performant, but for transparency stuff, it'd be really cool just to dump it on here. So we should probably have an opaque pass that we do. So I think before we do the map generation, it might be good to get that sorted out. So we've got a 16K limit as well on the number of yeah. Sorry, 64K because that's the quote-unquote triangle ID. And that holds the voxel ID, basically. Right, I'm just going to take a quick break, get another drink, and then we'll, I think we'll start on the opaque pass and render that way. And then do a transparency pass after that. I think that would be the wise thing to do. Then this should be better. So that way we can make it use the depth buffer and do a special optimization where it can check in the depth buffer if this object is further than yeah, there's some tricks we can do, I think. Yeah, you can say that the depth value is only going to increase when you change the depth inside the pixel shader, right? Because we're ray tracing into a volume, you can say it's only going to increase from this point, and then the driver can basically early out. It won't have to run the pixel shader on all instances, I think. That's what you can do. But yeah, we'll hopefully see some of that today. Right, BRB. Right, welcome back. Okay. So yeah, the plan was let's work because we got this sort of like transparency, order independent transparency render going on into a layer buffer, which is manually doing the depth buffering and all that inside the pixel shader using pixel shader interlocked. So it's pretty cool, but we probably want to make it such that it's not having to render the stuff which is underneath the floor and to ray trace into that if it's not going to actually render it on the screen. Yeah, stuff which is occluded, basically, it should be at least the depth buffer should be catching that. Because when we have like a map that we're drawing, you know, we probably want to have other bits of culling going on, but having an opaque pass is obviously a good idea. So I think let's start with that. And then we can worry about some of the other numbers because there's like a maximum number of 16K instances, right? And if that's the case, you know, we're already reaching that quite easy. Well, we're getting quite close, aren't we? So yeah, we've got to think about that too. How do we... I think we solved that problem with probably a layer of indirection. I reckon we can do it that way. But anywho, so it's doing a opaque pass. We can probably keep the... Yeah, we'll need different... We can copy these shaders basically. It should be quite easy to do. Right, where you at? So voxel render. So we'll do visibility buffer. Right, so if you don't know what visibility buffer is, it's effectively an object ID. So you've got 32 bits to render out. And then you do have a depth buffer in there as well. And it'll be done as in hardware, obviously, right? Rather than the software version we're doing for the order independent transparency right now. So the thing that we want to make sure that we're doing in this is, well, let's just get the push constants okay. So visibility buffer push constants. We don't want these two images in it, right? Just the stuff so we can ray trace. Then what we need, right, skip those. So visibility, okay. Right, so get the instance and that looks okay, I think. Yep. It's basically identical. Just a different push constants thing. Okay. Then, yeah, we could probably have the same push constants. It's just, yeah. Yeah, why don't we do that? It's fine. Yeah, because then you can have the same vertex shading, you know? Oh well. Okay. So, rather than being a layer buffer, so we don't do this interlocks thing anymore. So the thing we want to make sure is we want to somehow tell it that when we're changing the depth via frag depth, wherever it is, Oh, we're not doing with frag depth yet. So let's ask the AI about it. So GLSL frag depth, but only increasing. Is it called greater than? This allows it to. Yeah, this is what we want. One of these guys. Frag out. There we go. So this thing allows it to. What's the circumstance, right? So you have a value in the depth buffer which is let's say it's at 20. You've got an object which is at 40. So you're saying in your pixel shader that, and guarantee in the hardware, that my depth value is only going to stay the same or increase. So that means it could say, hang on a minute, the value inside the depth buffer is at 20, so we don't even have to invoke the pixel shader here, right? And that's the optimization that we're trying to get here, is to early out. So this basically stays the same, except for this part here, where we write it out. So we just do O depth equal depth in it. Yeah, depth. And then we need an O out O VB, I guess you call it, visibility buffer. Yeah. You do the visibility buffer, and that is the instance ref. There we go. Lovely. So we try and get this up and running. So render voxel render L. Okay, this is it. Cool. So you want to make a new one of these. Right, so one of them is wireframe. Yeah. LB wireframe. Maybe. I'm not sure if this is a good idea. Well. Right, so let's look for LB for layer buffer and swap out for visibility buffer, so VB. Cool. Keep moving. So now when we do the drawing, so this is render voxels here. So we should actually have a render transparency and a render. So render voxels. Render opaque voxels, render transparent voxels. So I don't know if we have. Oh, there's the wireframe as well in it. Yeah, that's a good point. It's basically this. Oh no, it's different. It's very different actually. Opaque, transparent. Where's the wireframes as well? Hang on a minute. The wireframe. Well, that just renders straight into the scene, didn't it? Yeah, let's sort that out actually. Let's go back to. That's very cool. I like that a lot. Right, so visibility buffer. So this needs to render into a. We need some color attachments and all this stuff. Sort that out. Where we go. Right. So we want a. The scene shaded image. There's the layer buffer. Where are you at? Yeah, so object layer buffer. This is it. So there's 4 layers of visibility buffer. We actually want to just get a single. There's the visibility buffer. And that will then be like merged with the layer buffer in another pass. Probably via a compute shader, I imagine, maybe. Potentially. Or maybe not. Oh yeah, probably via a compute shader, yeah. So we'll get those in there. So that'll be here. Clear, I guess. Store. Then the depth operator, I think. Depth right, true. Depth test, true. Culling back. What happened to the depth buff? Have we not got depth? Format. Yeah, there we go. So the format should be, I guess it's like D32. Yeah, we've done it here, haven't we? Cool. Yeah. Oh, it's down there. Cool. Okay. Very good. So nice. So when we it's draw 3D Z. This is our debug drawing. If we look here, we should be able to find how to set this up. So it's these 2 things here we need. Right, so find the voxel draw. Voxel. Opaque voxels. Put that in there. Right, so we want some color attachments. So we would array count. And then depth attachment spec. Nice, looking good. Right, so those images need to be initialized, and it's actually the scene uh, object visibility, and then scene. Yeah, what is it saying clear? Anyway, I'll look at that in a sec. We said right, so rather than layer buffer, it should be visibility buffer. You drop those two. And yeah, VB. Yeah, so load, clear then store. So yeah, that needs to be clear then store on here as well. Hmm. Huh. Oh, color attachment formats. Oh, right. Sorry, in the pipeline it's these guys. Wrong one. Whoopsie. So we need to still make these objects. Let's get them. So the blend state is just that. I want to grass in the end. Did I accidentally delete it? I think I did. Whoopsie. Right, so it was... Here we go. The address of this guy, yep. And the format, color attachment format. But the format is just going to be an R32 event. There we go. So now we've got to set up those images. So where we set up that scene, object, layer image thing. So we need to create these, initialize the temp resources. So it will be object visibility buffer image, and rather than object will be depth. Yep. Lovely. So now I'm just going to find where we actually allocate them at the beginning of the frame. So the temporary resources also right? So they have a lifetime of a frame. So this is inside the command buffer when we're recording it. Basically, we just say, right, allocate a new image. So these are the layer buffers. So they've got 4 layers, and the 4 layers are handled in software in the pixel shader. But we want a visibility buffer for the, yes, it's an RUN, and then just a D32 float. Cool. So we need a bunch of usage stuff on this basically. We want storage so we can like read from it in a compute shader, so we can like munge it together with a layer buffer at the end. But we want a color attachment bit basically on it. And do you need a transfer source on that anymore? Not anymore. Amazing. Yeah, but how does there's the depth image? Yeah, copy layer depth. It's right there, isn't it? No, it is happening. I was looking at the wrong one, I think. Right, so it gets cleared, and that needs transfer or something. Needs a special clearer, I think. Yeah, so I think that needs transfer. Something like that. Right. Okay, we'll leave that there. Right, so where was we? So we're looking at, so they need storage, so you can use it in a compute shader. And yeah, so this new depth one, just the visibility buffer, needs depth attachment. Okay, cool. So those, right. Now, the thing is we only have opaque instances. We don't really have transparency instances yet. Yeah, let's just say, so if we're going to have transparent objects, they need to be filtered out somehow, but yeah, we'll just ignore this for now. Yes, this is the transparency pass. So this should not use this here. So count equals 0, and we'll say to do, allow for, the graphics payload to pass in transparent objects, right? So it's the object as a whole, which is transparent. But yeah, this code should still basically work. Yeah, and then hopefully it should allow you to just do 0 instances. We'll see. So after that, the wireframe does allow you to do all the opaques there still. Very nice. Yeah, should be fine. And then, where was the other one? Yeah, so after we've rendered out these two, we now want to sort of merge the layer buffer into the visibility buffer into the layer buffer before scene shade, basically. Right, so what's scene shade? This one here, yeah? So we want to say merge VB into LB. And that'll just be like one of these guys, where it's got a lovely little compute shader in there. We'll call it something like graphics VK merge VB into LB. Push constants, right? So PC. So the what's the way of saying it? Yeah, so these two here, the layer images, and then we also want the VB images, yeah? So these will just be an RU32, that, and like that, I think, yeah? Nice. And then we'll just do a dispatch full screen basically. Where's the dims? Cool. That'll be a very specific pipeline. The compute pipelines this time. So merge visibility buffer to, did I say into? It should be into layer buffer. Good, yeah. Looking good. Now we just need to get this as a push constants. So we just gotta simply copy this. So this is shared between CPU and GPU, and it's using a bunch of macros to achieve such a thing. Yeah, these macros make our IDs type safe because we use bindless basically. So it's effectively just these guys, none of this sky stuff. Dims, copy paste that. So read only, oh, these are write onlys. Sorry, read writes and then read onlys on these guys. So that would be a visibility. Nice. And if we just save that, we're in a good place. No. So this needs to be, there is no R32F because I haven't done one yet. That's fine. No worries. GPU VK shared. Just needs to define another descriptor type, basically. There we go. Okay, these ones are complaining because they need to be a read write. Nice. That's why I needed the type safety, right? So when I do the sync code, it tell me what the problem is. Okay, so great, that gets called now. Cool. Now now we need the compute shader, right? So maybe we just do scene shade. I don't know, scene shade is quite big to be honest, but here we go. So merge LB, sorry, visibility buffer into layer buffer. Cool. So merge, nice. Merge LB, sorry, visibility buffer into layer buffer. Cool. So we get rid of all this stuff that we don't need. Goodbye. Now, so you do your sort of standard swizzle, sort of performant. So the way the layer buffer, sorry, the scene shade works is it goes over like all the layers, right? So I think what we're looking at doing is we want to read the depth. So that's a float. Read the object. So that'll be VB. Yep. So read that from the pixel coordinate. Now, if the depth is infinity, what did the clear do? Hang on. So Do, 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 do. Clear color could point infinity. Hang on, what are we doing again? So 0, is it less than, isn't it? Yeah, it's greater if it passes, I think. Let's find the pipeline, where you at? Do, 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 do. Depth compare greater. Oh yeah, but it's a reverse set, isn't it? Yeah. There's the draw 3DZ that knows how to do it. So we're sticking with, what are we doing? So, load. Oh boy. Right, what did we throw in there? So there was like a specific copy layered. Okay, so rest is linear. Yeah, I forget what we're doing here. We'll find out. I think it's either 0 or 1 basically you put there. I forget. But anyway, clear then store. Right, so back to where we were. So um well, if it's not enum, is it? It's the actual depth valley. Now let's just throw in there infinity. Probably not a good idea, but let's do it anyway. Right, so yeah, we can always debug print the value anyway, I think. Okay, so we're saying if it's infinity, then basically do nothing, right? So if depth infinity return. Cool. So now we need to scan over. So where's the layer buffer? This is the classical insert thing that we've been doing. So all we need to do is load the depth. Yes, load the depths. Let's get all this stuff here. Bye-bye. Right. So we've done a visibility buffer pass first, and then we did a transparency render pass using the order independent transparency, and now we're merging the two together. So it's as if you're taking the full screen of the visibility buffer and just trying to do the code which the transparency pass was doing at the end. So you load in all the values and you yes, you're loading all the values. If your depth is less than the depth at the back, you do a reverse search for where to insert while shifting the layers to the right. And then you find your insert location and store them back out. That's all you need to do. Cool. So with that done, that will then be the layer buffer being set with the visibility buffer stuff, and then the rest of the pipeline just works, right? So I think that's it. So let's try and get it working now. Didn't take too long, thankfully enough. All right, let's get some light. This will be a good optimization. Hopefully we get to see some numbers today. Right, so this sort of, okay, so the visibility buffer vertex shader does a, hang on, no, right, did this pixel interlocked thing, let's get rid of that. Got that out. Layout qualifier can only be applied to geofrag depth, right? So you've got to like actually use that. Right. Anyway. Cool. What's this saying now? So the compute shader is failing to compile because the merge 15. Yeah, I think that's just part of GLS, so it always returns a vector 4 because it likes to do stuff for you for some reason. Right, here we go. So it's compiling at least. And it's just got to mess with Vulkan a bit. So Vulkan's complaining that the pnex field is... Oh, what does this mean? So returned format not supported. Great. So I think it's because we're doing a depth stencil and we're trying to use it as storage or something like that. And I think those things... Yeah, there's some weird restrictions basically on GPUs where like if you use a depth buffer, it has to be this separate... It has to have a very limited number of usage flags. Oh, we can do sampled. Sampled will be fine. Yeah. Right, so how do we do that then? Yeah, I'm curious. Can I get rid of... I'll do it when it works. But yeah, so what you're saying is... Right. Anyway. Okay, so sample looks like it's a proper thing we can do. So we just got to find where we use it. So that's here. And we've got to use the sample. I think it's just called texture 2D. That's the one we want. So F. That's the thing. Now you just got to go into here and then say texture 2D F. Sorry, read just F maybe. There we go. Now it's got to find the merge and effectively use Texel fetch, I think it is. It's got to figure that out. Is it Texel fetch? Yeah, LED 0. Right, Texel fetch. And I've got to do something here. So it's texture 2DF. Text 2D read only. Is that a thing? Ooh. Is that a thing? Yes. So yep. Oh, it's the wrong one, damn it. Right, this one. Cool. So let's try. We'll do an LOD 0 though. There you go. Right, so we've got some other problem. Get closer. Here we go. So, format not supported. Oh, looks like I changed something else. Which did I do the wrong? All right, let's find the proper one this time. So 900. Sorry, 2196. Oh, it is. Hmm. Yeah, I don't know why this one is complaining because unless it's not been recompiled properly, and therefore it's just repeating the same. Yeah, okay. Maybe. Sampler. We need that. Fair enough, Sheila Cell. We'll do that as well then. Nice. Alright. So we're getting something. It's painfully wrong though. This is where I wish Renderdoc could be working right now, but it's not. So here's the visibility buffer. We're seeing it working, kind of. Got some kind of problems here though. For some reason. For some reason, voxel render LB is going in there, layer buffer. That's weird. So we want to look into that, that is for sure. So maybe we didn't rename it. Potentially. Mesh, Vox. Okay, looks like we just didn't rename it, so VB. Cool, okay. Looking good. So potentially it's the merge function not working, but we can sort that out. So if we bring up... Yeah, so the depth, visibility is there, the depth... Scene... Shaded. Where's the visibility scene? Ah, here it is. So this is not being rendered into at all. So that's probably the depth buffer is not, well, it is there apparently. But yeah, we can't see anything. So my thinking is, it's that depth value basically. I put infinity in there, I think. Where you at? It should probably just be 0. We'll try that out. Right. Still nothing here. But we are seeing a depth value encoded in here. So it should be in there. But it's not. So I'm very, very curious. It's passing it either way for some reason. So the next thing to do would just be to run a visibility buffer here. So the next thing would be just to say if is mouse at U coordinate, print the depth value. And let's just start there. So if we don't see any printing, then it's not obviously executing. Oh, we do. So we see it is executing, which is a good first step. So why? Why work? So we can then do a thing later on and just say, is it a hit? Right, so 2. That's a boolean, so it's probably like crying about it, going, it's not the right type. Right, so apparently it's a hit. So we're right. I didn't set the right voxel, I think. So I think we want to do this one and then dot bit filled 0, something like that. I think. I don't know. Wonder if that's complaining. Right, so do we see the... Still see nothing in here. Yeah, still nothing. So what could be the problem? So we are poking something out. So I guess you just see like, hey, what is it? So I want to see what that is. That will kind of be nice and helpful. Yeah, so it's something, right? So I reckon we might be putting it in the wrong texture, maybe? Oh, no. It's not passing the depth test. Ah, I see the problem. So you need to do this function to basically bring it into that sort of raster Z thing. So the other way around though. I nearly forgot about that. Yeah, so we need to like do this thing basically, right, where you're sort of like packing it. You're basically normalizing into 0 to 1 and storing it in the depth buffer. That's what you do. So what was happening is it was getting discarded after we wrote the value in, because it looked at it and was like, we got a pixel which is further in front or something. And so now I think we're just trying to let's just double check it with some other one we've got. Yeah, so doesn't draw 3D. So I think now we just got to initialize the proper value. So yeah, so maybe we'll try the infinity thing again. Let's try that. Nope. Don't know why these things are still here, but anyway, some weird lines. But yeah, this one is the one we're trying to look out for. This is not even being copied in here properly. Yeah. It would be great to try a render doc, but I can't. We couldn't get it working today. Don't know why. Just does this. It's really bizarre. Can I go to like... Even like... That's not working now. Things, man. What is going on? Right, got a hay there now. So, comes now. You're fine. Right, got a hay. So it seems like it's not pushing a frame for some reason. There is a sort of... So there's the hot reload thing. There's these sort of build events and all that. Maybe this build events thing is like doing something. Because the build system's not there or whatever. Can I get some in here? Did we get that far? Apparently not. That's very strange because game render gets called like it's part of it's part of the main loop. So it seems like it doesn't even go all the way through in it. Yeah, no hay. Yeah, there's no hay. Very sad. Bizarre. So I think it's just in game in it. That's the problem. So let's do one before here. Just put a few down. See what happens. Build it. There you go. So there's 3 of those things. Let's do for render doc now. That's the build system doing its thing. Hang on a minute. Right again. Ah, so I've got 3 of them. Let's go ahead. This is so strange. So you're telling me that It does get initialized. Used. Alright, let's put one there, there, there. So maybe it can't get the payload. Oh yeah, so right. Maybe the game logic thread doesn't produce a frame. Yeah, okay. Right. So it's forever waiting for a frame for some reason. Like, so this is not a render doc exclusive problem. This also happens when, what can we say? When we double click on the executable, it just happens this way. So, yeah, so it should be kicking this guy off, right? And then this thing goes, then it's not reloading. Right, let's do a different one. See what happens there. Now let's see what the render dog wants to do. Okay, sure. I'll do that. Oh, we got four of these guys. 1, 2, 3, 4, which means the problem is happening in here. The best way to debug is printf, apparently. So it seems like it's somewhere in here. Put one there, one there, one there, one there, one here, and the final one done. I don't reckon it gets it done, obviously. Let's make the second last one a bit of a different one as well. Okay, here we go. So you bugger, what's going on? When did you decide to not do anything? Are you telling me? Right, so it wasn't anything to do with this function. Although I'm pretty sure it was. Aha. So it's not then. It is interesting. What is this? So it's ticking. Tick, tick, what? So I guess it doesn't. Does it do infinite tick? Nah, just goes in there once. Right, so somewhere inside. It has to be somewhere inside this tick go then. So maybe it's the inputs? Can't do all four of those surely. Alright, let's try that out. Did all four of them. Interesting. That means it's something to do with the UI. Have a look at that. Yeah, it's crazy. uh, the only thing I can resort to, I think, though, but it gets there. So 1, 2 doesn't do a third. Don't do a graphics, maybe. Bizarre. Oh, it might be to do with the game material palettes UI because we recently added that. Right. I just need to I'll be right back. I need to sort something out. I'll be right back though, and we'll carry on. Right, I'm back. Welcome back. We're doing some deep printf debugging. So I think it's in game UI. I gotta find that out. Just get rid of that quick. Pop that open. So how many we got? It's got 3 of them. 1, 2, 3. So it is inside game UI as I was thinking. So basically, right, I added a new thing called material palettes UI, and this is all new code. So something in here might have an infinite loop, maybe. Ah, you know one way we can catch this, I think. If we run it in the debugger, but directly run the game. Hang on a minute. So that would be build package debug. Try that for me, please. No. Right, so the debugger doesn't, it kind of runs it from a, it doesn't run it in the same way as it does when you double click on the executable. Okay, so it's not an easy way to find it out, unfortunately. Right, so somewhere in here, in the game palette thing, I think there's like an infinite loop, basically. So you won't have... Alright, here we go. It'll be this side of the if statement here because you're not going to have the... Well, let's see if it gets here first. Alright, it doesn't. Cool. That's eliminated that. So it doesn't even start up. Let's see if it reaches into here. Come on. Okay, it's not to do with the new material palette UI. Interesting, to say the least. Let's try that out. Okay, so we've got two of those, but not a third one. That could mean many things. So there's no loops in here though, you know? I'm wondering whether it's just kind of crashing, but... So it should be... Is it inside this panel thing? So that means panel to open, it should be opening. Drop a few in. That's not very sensible to split those out. Let's try that. See, I used to have a function which was, or a macro called like debug here, and it would print out like the line number in the file sometimes. So that might have been better to do. But anyway, we've been doing this. Right, so we got 1, 2, 5, 5, 6, got two of those. So it is kind of stopping inside this function. 1, 2. So it's okay. I think I see what's going on. It's something to do with the event thread. So basically, right, it does the UI window open. It does an OS window open, and then it says, go on, open a window then to another thread. And then it waits. It never comes back. So there's something about when you open it from a terminal. Okay, I've got some ideas. So isn't there a win main in here or something? Or no, 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 no. Right, so there's sort of this persistent thread thing, and then it calls. Yeah, so I don't think the event thread gets booted up, basically. There's some, I don't know why. Yeah. You have to have like a separate thread to dispatch your calls on, and then like I've got a DLL which gets hot reloaded, so it needs to remain persistent. So the function is living inside the DLL that gets called. Yeah, Windows stuff. Windows. Right, so there it is, the event thread there. It is being kicked off. But for some reason, well, we haven't verified that's the problem. Can I quickly just verify that's the problem first? So, os.c window open. Yeah. Yeah, there you go. So let's verify that's the problem. So if we go to the event thread, so that'd be an OS Windows. Thread main, something like that. So I guess you just start littering in here, right? Did we get to there basically? Wow, interestingly enough, that doesn't work. Huh. Oh, there we go, cool. Right, so let's open it up in Renodoc. Cool, so we've just got 1, 2, 3, 4. Oh, we got there, okay. So it's getting there, but it's not like waking up. So there's that wake, there's a wake function or something like that. There's like a request, backend request queue end. Yeah, so post. Yeah, so maybe what happens is the game gets in there quicker than this request handle gets made. And yeah, I think that's a problem. So this might not be made yet. So we can test that theory out by simply printing. Mm-hmm. Mm-hmm. Going to run it in here. There you go, 0. Bum, bum, bum. There's your answer. So yeah, it's sort of like a race condition, right? So it's strange. If you double click on it, like the main window, or the main thread initialization gets to creating a window before the event thread does. It's weird. It's maybe something to do with how the threads get scheduled and stuff like that. But yeah, so anyway, I'm glad we found it, right? But how do we solve it? So, like, so when you dispatch this, right, backend in it, you want, yeah, okay, easy answer. You do that job barrier thing. So the problem is you can't pass in the argument, but it should be fine because we've got globals. So essentially we just make another job barrier. You call it event thread init or job barrier, something like that. So you instantiate this boy. So yeah, I was making it like do a bunch of initialization on another thread as well. So this does kind of suck. But yeah, we can optimize it later, so it's not a big deal. Oh, wrong one. Hey there, how's it going, Mayo? Welcome, sir. What am I doing? Currently fixing a bug. We're kind of, I think, 2 layers deep down a rabbit hole. So we're trying to fix a bug, and it's getting in the way of us debugging a problem to do with our visibility buffer pass. And within a visibility buffer pass, because we're trying to optimize the renderer for handling a procedurally generated map. So we're just trying to make sure that everything's ready before we go and procedurally generate a map, basically. That's what we're doing. How many jobs do we need? That's in the initial jobs, and it says 0, I think. Is that right? Yeah, so you can say you got a job. Yeah, it's got 1 job. And then you wait for the job to be done. No. Yeah, I could have just done it as a semaphore, I think. I got this thing too. This works just fine. Oh, come on, what's going on here? Excuse me. Alright, so we just gotta jam this in here somewhere. So, like, now everything's initialized. So we just give it a job or whatever. Yeah, where have we used this thing before? What do we do? Job done. Yeah, job done. Yeah, this waits till all jobs are done, aren't they? Yeah, so you give it a job. Okay, so that should fix our problem, basically. And then it should run in render.doc once again. Right, here we go. Boom. It works in render.doc finally. Capture. Now we can debug our problem. Is this a game engine? Yeah, it's a custom game engine. Now, the game's not ready yet. We literally just started on it today, day 1. So yeah, got quite a few more days before it's done. But we're going towards doing a vertical slice and then doing a expanding out from there. We're just starting on the map. Rendering, cool. I'm thinking about making one myself. Awesome. What are you? what's my denomination? You're a Protestant. Yeah, I don't think Protestant is necessarily a denomination. It kind of is, right? Or it was at some point, but now it's like branched off into sub denominations, hasn't it? But yeah, uh, yeah, I would class myself as that as well. I wouldn't. I'll go to a Pentecostal, um, but yeah, um, I believe that we're saved by grace through faith. It's the faith, not of works. Faith in the death, burial, and resurrection, and the blood. Um, yeah, and yeah, that's basically it. You know, all I would say. Um, but yeah, how long have you been a Christian for? Um, no, I'm in the UK. I don't know why it's saying that time zone. Where are you finding that time zone from? What's the name of the game engine? It's the Heroes game engine. It's a little custom one. So it's obviously named after our Lord and Savior Jesus Christ, the fact that he rose from the grave. But it's kind of made up from my name as well, a little bit. Yeah, so what this capture, we're trying to find. What was the problem again? Yes, the visibility buffer renders, and what's the problem with it? It doesn't. Yeah, the depth. It might not. It's probably right. I know what it's doing. It's this one here in it. Yes, here's our boy. So it should have cleared the depth pass. Um. Oh no, I should have done debug. Yeah, here we go. So we did a draw, and the reason why it didn't work is because the shader outputted. Yeah, so before the text word a 1 in the depth. So if I put a 0 in there, maybe it's fine. Sure, we tried that last time. Ah, right, that widget down there, that might be the reason why the times are wrong. I see now. Yeah, I'll look at that afterwards. Thank you for pointing that out. I'll fix that. Because the times have been incorrect and messed up. Lutheran for me, but Lutero didn't want to name like this to kind of avoid. Right, so you mean Martin Luther, did he not like that sort of name? Um, oh, does it say, okay, it adapts, fair enough. Right, so maybe is where the individual is from and not me. You didn't want his name to be part of the denomination. Okay. It's very humble. But yeah, the whole Christian denomination thing is, like when someone tells you what denomination they're from, it doesn't necessarily mean much sometimes. Um, like even if they're like a Jehovah's Witness, right? Because you would go and actually speak to them, and you basically have to like figure out if this person actually believes in the denomination that they are going to, um, or what different things do they believe to that basic model. And so it all kind of is a bit meaningless um, at the same time. But yeah. Right, so we clear the depth to infinity here. Right, that's basically the same thing, isn't it? Hmm. Right, I think I have an idea of what went wrong. It might have been putting it to an integer. Oh no. Yeah, I'm not sure what it did. Should have been putting in the float field. Right, we've got a 0 in there now. Let's have a look. See what Renadoc thinks. So 66. Right, let's pop it in there again. In my opinion, if you haven't read the Bible, the denomination is least of your worries. Yeah, true. Yeah, because, like, you're probably, like, you're just believing what man says over what the Word of God says at that point, aren't you? Right, this is interesting. What we got now? So before, after. Nice. So that's fine. No, 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 no. Yes, that clears it to 0. 4 fragments touching the pixel. 1 primitive does it. So why don't we see anything? Right, let's take it out of Renadoc now. I think we're okay. We'll see. That seems like it's doing the right thing. It's going to our own thing. Right, what we're going to do now is just poke something else in there. VB, FS, yeah. So we can just do the X value, something like that. See what happens. So poke in there. Oh, T-style cast don't work. Yeah, the black white's a bit crazy. Is the pipeline set up right? Probably something dumb like that in it. Rasterizer, I guess. That looks pretty sensible to me. Depth clip, that's an interesting one. Yeah, I think you want that. I think that's alright. Can I analyze that in the pixel shader? Yeah, so maybe the... Something about that is wrong. Because the value is there, it's the right value. Maybe I don't need to do that. Right, you might say flat out. No, 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 no. Interesting. That's only doing... Right. Fragment shader. Right to attachment 0. 450. U32. Oh, you might have to do a UVEC 4. No, 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 no. That's what we got in it. Hmm. Right, it seems like that was a miss at the end. Okay, so the one which actually wrote... Oh, what's that? So R is that sort of red channel, yeah? So shade it out, but then for some reason when it passes... No. Is a print of 0 makes it pass. Ah, strange. You got your web GPU version about the same as your metal version. Oh, amazing. That's cool. Yeah, so that means you can at least make a demo on itch and all that. That's great. Yeah. And I guess you can make it work on other platforms too. Bits that don't work here, you do better on. I just swallow my objections to WGS. So yeah, it's sad. Been holding my project back to WebGL because I was having a web build instantly accessible. Exactly. That is the one cool thing about it is you get the web build. You know, well, it's a pain in the butt to like maintain and obviously get to work because there's like a maximum amount of memory and you know, threads I'm sure are not quite the same. I don't know. I forget those things. But yeah, I hear though the thing to do at the moment is make a demo available on itch and let's see if people sort of like it basically um there. But yeah, obviously you can make a demo on Steam these days. That's the alternative way to do it. That's probably the way I'll do it. Similarly, it doesn't like the idea of using. Oh, you don't like the idea of using a wrapper API instead of the real. Right. But WebGPU happens to be baked into the browser, which is huge. Yeah. Yeah, it is a wrapper API, isn't it? Yep. Alright, what the crap's going on here? So, why does it say R0? So that's the one that does it, but it's. That's super confused. This is just so dumb, man. Super dumb. Right? Ta-da! So then, like, this one here, they're all output something. Let's try this one. Run forward to here. Come on, work with me. Yeah. Man, confusing. So we could just disable depth testing at this point and see what happens. It's the other way to do it. So, graphics. Visibility buffer. We find there's the pipeline. So if we say they always pass, let's try that. See what happens. Right, so it's always passing and apparently always failing. A lot of stuff going on here. Get out. So 66. Oh, is there like an alpha blend? Is there like an alpha blend going on? No, there's not, is there? I still don't have blindness, but it's a huge step forward. Yeah. Yeah, that's the problem with WebGPU in it. That restriction. Oh, maybe it's never we're supposed to be using. Right, it's disable depth test. Right, surprisingly, this did an error. Even though we hooked up a depth attachment. But yeah, so even if we render it to it directly, so we go to the visibility buffer fragment. If we take out this and this, I don't think I saved all the files. Yeah, so that was the assert I was looking for actually. So I think we just comment that out there. Let's try that. This is crazy. So supposedly what's going on is we've got no depth anything going on. And it's still. Well, we don't know for oh yeah, still not doing it. History. 2 fragments. Both output 384. With no depth or anything like that. But the second one, after the fact, it's like, hey, your red is now 0. We're using store as well, yeah. Right, let's go to like scene shaded image. There's a color attachment and yeah, it's only used in there. Now this is bizarre. R32 unit. Fine, isn't it? Hmm. Rather bizarre. So what could make R be set back to 0 again after? I wonder if this would be an interesting test case for Gemini if it does images. It does, right? Huh? I just took a picture of that. I made it text. That's interesting to say the least. Do 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 do. Right, so in render dark, the shader out red is 834, whatever, but text to laughter red is 0 with no depth buffer or other primitives. Let's say other primitives. See if it's got any ideas. Image of fragment shader was successfully executed, output the correct raw value, but the GPU hardware discarded or clamps the value during the frame buffer at the right stage. Maybe. Yeah, I wonder too what's doing it. It might be is probably the Windows screen capture tool is doing it. So when it puts into the clipboard, it puts an image and a text version into the clipboard. That's what it does. Yes. So if your JSL outputs or uint, but you bind color attachment 0 as floating point, yeah, could the format be wrong in the pipeline? That might be it, the pipeline. No, it's not. It's correct, it's right there. And it's stack as well. Alright, you're doing good. Right, next one. Color right mask is disabled, that's a big no-no, they're all there. RG, oh, it's doing RGBNA. We just needed an R. Potentially problem, but maybe not. Blending is not enabled. Because blending goes in here, right? And it's not enabled. Let's try that. Nah. Well, yeah, it's none of those, unfortunately. Not bad ideas, though. Let's see what Renadoc's picking up on. What's this blend factor thing about? Yeah, that's target blends. There should be. Oh, that is interesting. Alright, I found the problem, guys. I found the problem. I found the problem. You're gonna love me. That one was not 0. There we go. Fixed it. Cool. Object has now got an object in there. Looking good. Okay. Final one is we're not seeing it in the scene. So the layer object image is there. And the depth is there also. So I'm wondering whether or not so if there's not an object in there or something we need to encode. So I think in that merge pass we need to print out basically. Mm. Yeah, so I think this needs to do that raster conversion thing right out. So if is mouse at this, yeah. Yes, you see here it says 0 to 1. That's the problem. Yeah, AI is sneaking into everywhere, and it is everyone's putting it into products everywhere, even if it doesn't really make sense. But they can just sell it as AI being in the thing. Right, raster depth. Linear depth from raster depth. So what does that look like? Does it give me an infinity? Or it gives me a 60 or whatever. Cool. So we want that. So depth equal. Yes, insert layer 0. Nice. So it's going in there. With the right value now. It's just why then is the scene shade blue? Scene shading pass. Yeah, it's correct, isn't it? So What makes you say it's blue though? Yeah, they're looking alright. Yes, the merge happens here. Um, that is way better if that's so. Because it was around like 2 milliseconds, I think, before, and but it's not really rendered in the right scene shade for some reason. Not sure why. Let's see what this is here. Yeah, it's just solid, isn't it? So potentially, if we just get all the bits out, so we want to see like what is your, hang on a minute, say UVEC in it. Yeah, so we want voxel index. We would like an instance index. And maybe that's okay. We're not seeing that here. Okay, so the kind that's being extracted is 0. Yeah, these things, man. So I'm pretty sure I changed that. That was in the... The cogen might be messing up. Not sure. It's definitely changed. So I don't know what's going on with this, but so open, build, cache, debug, graphics. This is the one. Yeah, seems alright, I think. Most code gen stuff. Yeah, some of them not being inf. That's the problem. So we're basically then I just need to make this go to be infinite. So in the merge code, basically if it's equal to min or max to max, make it inf. Yes, if is equal to bar, something like that. Mm. Wow. Uh, weird. Hey JD Husk, has anyone here in the chat ever tried simulating the ocean waves? No, not yet. Not yet. I'll probably be using some kind of water soon, maybe. Hmm. Right, so what values are in there now? They seem kind of uninitialized, I think. Feel like it. Graphics, VK, the layer image. They might not be cleared now. Yeah, we should look at the depth. It gets explicitly cleared still, right? Yeah. So, all right. So go back to scene shade. The depth. Huh. Yes, it seems like the kind that you're reading back is just incorrect for some reason. And I don't know why. It could be to do with the packing code. Seems alright to me. Oh, we're not setting the depth. Huh. Oh, then we stored the depth value out here. I completely forgot we changed that. Right, easy peasy now. Super bizarre then. Boom, we're back in business. Right, now we can check the performance. See how it compares. But quickly, I want to double check. This, right? Like, yep, so we do need it to do that. Nice. All right, we're in business now. This is good. This is amazing. Right, so we went from a layer buffer to a visibility buffer. And the reason why is because yeah. So this pass used to take, just to render all these, it's a 64 by 64, and I think there's a layer, there's only one layer of them at the moment. But that alone used to be 2.3 milliseconds or something like that. But now it cost 0.24 milliseconds to render all those, and then an additional, ignoring the stalls here, it takes an additional 0.26 milliseconds. So all in all, it's about 0.5 milliseconds to render into the layer buffer now, and it only renders into the front. Now the layer buffer is there for order independent transparency. So if a transparency passes, obviously we can still do those. And the reason why it was slower is because for overlapping, well, one, it was outputting 4 times as much information into 4 layers. Yeah, so it'd be a U32 times 4 rather than just a single U32. And also 4 values of depth. But with this new approach, it's just doing the classical, the color is just a single U32 and the depth is a single float 32. And it's able to early out because it's using a hardware depth buffer, whereas the order independent transparency is done in software, right? Using the pixel shader interlocked thing, which we saw earlier. So now the beautiful thing about this is if we take game.seat, where's the logic render? Right. So we take this here and we up the number of layers to have another layer. It shouldn't change this too much, or maybe at all. Let's try. Right, crashed. It crashed. So wait for it to finish. There we go. So let's try it now. We'll see the results. Okay, so that went to end up being, right, it kind of doubled. Did it? Yeah. It nearly went double, just a little bit less, but that's fine because it's way better than the other one. Although you would be expecting it to sort of, hang on. I forgot my optimization thing. Depth greater. That's the thing we want. Otherwise it's not going to be able to early out. And here we go, what do we get now? So we've got 2 layers of voxels now. See the 2 layers thick. And we press F9. I'm not really seeing it. Yeah, still looking the same. Mm. Yeah, I don't know. I don't know why it's not doing any better. The pipeline stays in the right place. Or maybe you meant to say depth less than, I think. Because it might be talking about... Yeah, I think we want to do depth less instead. Because it's in reverse Z. That might be it. It's not doing it. Um, your depth value is set to less. Right, let's see if that'll work. What about with this? I think that is it. Yes, that's what we want. That is with less. Okay. But it might not be working because the way they're so tightly packed together. Okay. Anywho. At least we got that in the right place. But yeah, it's way better. It's much faster than it was before. So it's like over 10 times quicker. So good job. Okay. So that's good. Right, it's a good place to be at. Yes. So yeah, so you know, after this stream today, we can safely say that the performance of the render is probably fine in terms of that how we're rendering the voxels for the map. The next thing we should probably do next stream is like how we might want to we need to somehow figure out how to cull the voxels basically. So how do we cull those voxels and make it such that we can take a big map and then send it to the render thread basically? How do we do that? Because we cannot render over 65,000 I think, or sorry, 16,000. We can't do it. So yeah, we've got to figure out how do we take a very big voxel map and somehow cut that up and give to the renderer. But yeah, so that'll be on Tuesday at 7:30 p.m. GMT +1. Also another stream as well on Thursday at the same time. But yeah, the schedule's all down below, by the way. But if you guys are interested in the game that we're making, you can go and find the devlog. The devlog? I don't know. It's a presentation. Kind of like a pitch thing. It's on YouTube. Just go check it out. But yeah, there's also Discord if you can come and chat in the meantime. And if you want to support the channel as well. Oh, I've lost some things. Where's it going? There we go. You can support the channel via Ko-Fi as well. And thank you for everyone who's doing that already. Appreciate you all. And appreciate you all for coming. We ran a bit long today, but there was bugs I wanted to get solved, and bugs are fixed. But anyways, great. Good day, guys. Bye. God bless you all.